So the topic of today's presentation is about vectors. And this is going to be an introduction to you to vectors. What you need to do during this presentation is learn about vectors. I suggest that you take some notes in your notebook because there will be an assessment on this material at the conclusion of this presentation. And you may use whatever notes you take to answer the questions on that assessment. So the more and better notes you take, probably the better you're going to score. But the most important thing here is to learn something, to learn about what a vector is. First of all, a vector is a quantity. It's a number, but it's not a counting number. For example, here I've got 1, 2, 3 markers. Saying I have 3 markers is a count. It is not a vector. A vector is a quantity that is said to have both a magnitude and a direction. Now, that's the definition of what a vector is. So we're going to pause here for a second. So there was my pause. I wanted to give you a good working definition of what a vector is. A vector is a quantity. It's a something. And it is going to be numeric, but it is a quantity that has both a magnitude and a direction associated. So we're going to have a number and we are going to have a direction. This word magnitude is kind of a fancy way for saying how big. That's what magnitude describes for us. It's how big or how small something is. This is going to be the number part of our vector, and it has a certain magnitude. The magnitude of 3 is greater than the magnitude of 1. So a vector is some quantity, and it has a number associated with this that tells us how big it is. For example, something like 100 is going to be greater than 5. It's simple numbers. That's the magnitude part of this. However, a vector also has a direction. It's not just a number. It's a number that is going some particular way. That's the where part to this. So we've got the magnitude that describes how big this quantity is, and we have the direction that's the where part to this. Let's look at another quantity. So we take this pencil, and it's a measure that we can make. We can measure the length of this pencil. Length of a pencil is not a vector. Here's why length is not a vector. There is a magnitude, there is a how big to this, but there isn't a direction. This pencil is about 19 centimeters long, but it's 19 centimeters long right now going this direction. It's still 19 centimeters long in that direction or in that direction. You don't need to describe which way the pencil is oriented in order to measure the length of that pencil. Therefore, the length is a measurement that is not a vector. Just a real quick clarification about magnitude, however, the idea of what magnitude is. Magnitude is how big. Now, bigger lengths, we would say, would have a larger magnitude, even though it's still not a vector. So this pencil has a bigger magnitude length than this one. Let's look at this sample of sand here in this little weighing boat. Got some sand in here. And we quantify the amount of sand in there by its mass. We could put this on a triple beam balance or electronic balance, and we know that the more mass, the more sand there is, the greater the mass. Mass is not a vector because it's an amount. It's a count of how many little grains of sand are in there. Mass and length are what we call scalar quantities. A scalar is a quantity that does not have direction associated with it, like mass, like length. So let's compare a scalar to a vector. An example of a vector here would be force. If you remember from your 8th grade physical science, that force is defined as a push or a pull. I want you to think about pushing or pulling on this car. You have to push a certain way. You have to push that direction, or I can push this direction, or that direction. In order to push or pull, you must apply a direction. You just can't push or pull and not push in the direction. Therefore, force is very definitely a vector quantity because it happens in a certain direction. Going back to my sand, we already said that mass is not a vector. How much sand is simply a scalar. It's a count. It's a measurement of how much sand is in there. There's no direction associated with it. But the weight of this sand is actually going to be a vector. And I want you to think about the weight of something. How do you get something's weight? Well, gravity pulls it. Which way does gravity pull something? It always pulls it down in that one direction. Gravity works in a direction. So something's weight, which is caused by gravity pulling down, must be a vector. Think about that. It makes sense. You step on a bathroom scale, your weight is pulled down. It's never pulled up. It's never pulled side to side. A bathroom scale only works if your weight is pushing down on top of it. So a vector quantity that corresponds to mass would be weight, because weight only works down. Let's get back to my toy car here. I'm going to make my toy car move. Make it move that direction. And granted, I gave a little force. We already said that is very definitely a vector quantity. But we would describe this toy car by how fast it is moving. It has a certain speed to it. Now, let's just say this car is moving at 1 meter per second. Now, 1 meter per second could also be moving that direction or that direction. The speed of something just corresponds to how fast it is covering a distance. How fast is it moving? It doesn't tell you which way you're moving. And if you think about a speedometer in a car, it doesn't tell you where you're going. It just tells you, oh, I'm going 55 miles per hour. You could be going 55 miles an hour, north, south, east, west. It doesn't matter. Speed is very definitely a scalar quantity because it does not have any direction associated with it. However, there's a corresponding vector to that scalar of speed, and that is called velocity. Velocity is how fast something is moving and what direction. That car has a velocity going that way. It has a velocity going that direction. Velocity going this direction, or even that direction. So velocity describes both the speed and the direction that something is traveling. Now, this is going to lend into our next discussion. Well, how do I describe the direction? With weight, it was easy because we know weight only pulls down. But for velocity, I got to have a way to express the direction. We know that all vectors have a magnitude. All vectors have a magnitude, which is just the number, the how big part, and direction. The question is, how do we express direction? This is going to be a number. It's going to be 1, it's going to be 7, it's going to be 1256. It's some number. And the bigger the number, we know the bigger the magnitude. But how do we describe the direction? So my toy car, I could describe its velocity as it's going 1 meter per second to the left, or it could be 1 meter per second to the right. Say 1 meter per second up or 1 meter per second down. You can describe direction as left and right. You could say up and down. The problem becomes when we start to do math. How do we mathematically express left and right or up and down? If you were hanging upside down, your sense of up and down would be different than somebody who was standing straight up. Same thing with left and right. So we need a better way to describe direction. It's not bad, but we can't do math with it. Think about algebra and think about the motion or the movement of something. If we go this way in the x direction, we're moving to the right versus going to the left. And we have always called this the positive direction for x, and this is the negative direction for x. The same is true for the y. We've called this the positive y. We've called that the negative y. And if I gave you this, you know that that's the positive. If I said go to positive 4y, you know to go up. So your direction can also be expressed as positive and negative. And that's going to be very helpful because then we know how to do math with positives and negatives. Now, in physics, we're going to be working with stuff in the real world, not numbers on a Cartesian coordinate system like we did in Algebra 2, although that's helpful. Think about if we start here in Atlanta and we move a certain distance away from Atlanta. And I say, let's move 100 miles away from Atlanta. Well, that could be 100 miles in any direction. Maybe that's 100 miles, that's 100 miles, that's 100 miles, or that's 100 miles. So you could have anything within that circle be at a distance of 100 miles. Well, that doesn't tell you which way you moved or your direction from Atlanta. So the term distance is a scalar quantity. It tells you the how far part, but it doesn't tell you the where. So we're going to add that here. Distance is just how far away you were or how far you moved. It doesn't tell you where you moved. There is a corresponding vector to distance, and it is called displacement. Displacement, this is our first big physics unit of discussion here, distance versus displacement. Displacement is not just how far away you are, but in what direction. So now, if we want to describe the displacement from Atlanta, I might say I went this far north as opposed to that same distance west. This is an example of distance versus displacement. Distance is how far. Displacement is how far and in which direction did you move. Notice I used some words here. I used north and I used west. That's another way in which you can describe the direction of a vector. We use left, right, up, down, positive, negative. We can also use north, south, east, and west, and we will, because that tells you which direction that vector was acting in. So let's look at this here. Imagine that I start at the origin, and let's say I go 5 centimeters this way. We really like to graphically represent our vectors. This, however, is not a vector. I have some length here of 5 centimeters. I have some distance, but I don't know direction. Think about how I drew this. Which way did I draw this? Well, I started here and I went this direction. Well, how can I indicate this on this drawing? Vectors are represented by arrows. So you have the length of the line that indicates the magnitude or how big it is. And the arrow point at the end tells you which direction you were going. If you want to think about this as a map, you're going northeast. You went 5 centimeters northeast. Now, vectors can also be combined. Imagine now I go and I walk a second vector. I've gone 3 centimeters that way. I still drew it with an arrow. I said instead of going 3 centimeters this way, I went 3 centimeters this direction. The two ends of the vector are called the head and the tail. The head of the vector is the side that is drawn the arrow. Think about this as being like a snake slithering along. The front end that tells you which direction it's traveling is the head, and then that would be the tail. Same with vectors. This is the head, this is the tail. Well, now I've got two vectors. My distance is 5 and 3. I've traveled a total of 8. Okay. But now imagine that I now travel this vector, a 4. My distance traveled is 5, 3, and 4. I moved a distance of 12 centimeters. But how far am I from where I started? 0. I wound up back at the same spot. That's what displacement is. Displacement is how far from where you started. So in this case, if I add together my 3 vectors, because I made 3 separate trips, I went a certain distance in a certain direction, then I went in that distance in that direction, and I went that distance in that direction. My displacement in this case was 0. My distance traveled was 12 centimeters. My displacement, which is how far do I wind up from where I started, in this case is 0. This is our first big topic of physics discussion. It's going to be the displacement, or where have we physically moved? How far in one direction from where we started? And one thing I do want to point out about vectors, the magnitude of vectors are always positive values. You can't describe how big something is with a negative number. You're not -3 big. You're not -12 big. The size of the quantity is just the number. It's 3 or it's 12. So what does the positive and negative tell you in a vector quantity? The positive and negative tells you direction. Whichever direction you decide to be positive or negative, the positives and the negatives tell you direction. There is no such thing as a negative magnitude, because you can't be negative big. You're either 0 or you are something. Okay, so at this point, we're going to take that same quiz again about vectors and see how much have you learned from this presentation.